Good morning from Europe. My name is Schaer. I am the chairman of the Working Party on Education of the European Federation of Chemical Engineering. Welcome to all of you for that spotlight dedicated to education. Before we begin, I leave the floor to Hermann to say a few words about the European Federation of Chemical Engineering. Hermann Feise is the president of the European Federation of Chemical Engineering.
Thank you, Eric. Yes, as the president of the European Federation of Chemical Engineers, it's my pleasure to welcome you here to this event in our series of spotlight talks on significant topics in chemical engineering. And as the EFCE, very proud of this series and the 11 technical groups of EFCE who have taken on the challenge of delivering such sessions. And we've talked about chemical reaction engineering. We've talked about mechanics of particulate solids. Today we'll do education, and it will go all the way to thermodynamics and transport properties. And each session focusing on key topic areas and allowing people to join and look into other subjects. And that's kind of a new thing EFCE does in its strive to promote scientific collaboration across Europe. You know, we represent about 100,000 chemical engineers in about 30 different countries. And the heart of what we do are the working parties and sections that cover the core of chemical engineering, all the way from quality by design to fluid separations. And we're very proud that we're able to do this. And I would like to encourage you to look into the ones that will still happen this week, like this afternoon into energy or tomorrow into mixing. And let me also take the opportunity to thank Martin and Ines, who have made this possible, who are in the core of organizing this thing, for all the hard work they put into this. And with that, I'd like to wish you all and us all a very good and very interesting Spotlight seminar today.
Thank you, Mr. President. Thank you, Hermann. So today we'll have a webinar series dedicated to education. We'll have three presentations given by Jarka, Glassey, Marcel, Liauw, and Szekely, and they will speak about the transposition of the application of active teaching methodologies into distant learning. So each presentation will be followed by time for question and discussion. So please use the chat, the question and answer chat, to ask any question or to send any comment. Just before we begin, a few words about the Working Party education. Its objectives are to bring together people involved in chemical engineering education to discuss latest pedagogical evolutions, both from the content and form point of view. It regroups more than 30 members, both academics and industrialists, from different European countries. So please feel free to visit our website, where you could find some information dealing with education, and particularly the latest version of the EFCE Bologna recommendations for the implementation of chemical engineering education. And very soon, you will see also some 2-page flyers for the description of active teaching methodology. So that's all for the description of the Working Party. So I will let Jarka begin and enjoy the spotlight talk on education.
Thank you, Eric. And let's see if we can share this. And I'll try to put it in a presenter mode. Can you, Eric, just quickly let me know it's visible and it's presenter mode?
It's perfect.
Brilliant. Okay. So first of all, thank you very much for giving me this opportunity to share some of our sort of learning from this very rapidly changing world. I think it affected us all in ways that we've never sort of anticipated, I guess. As a microbiologist or biochemical engineer, I was just wondering, you know, when that would happen rather than if. But here we are, and I think the face of higher education has probably changed the most, in the sense that a number of things we have been used to doing differently, we will now have to significantly change. And even if we were doing a lot of active methods of learning in the past, I think the way that we will engage with the students from now onwards will change, I think, quite radically. So today I'm going to try to share with you some experiences from Newcastle University, where I am a professor of chemical engineering, and you can see a lovely sunny Newcastle, which of course it is always sunny in the northeast of England, or maybe not. And it is in a very specific area of advanced modeling skills, which have gained much more dominance recently, particularly with the advance of digitalization, Industry 4.0. So the question I'm going to be addressing is, how do we carry on developing these modeling skills still in the COVID-19 affected environment, but how do we then go forward with the post-COVID-19 era? And I guess an educator would always ask, so how do I ensure the same or even higher quality of learning experience for my students if I'm delivering most of that learning currently, at least remotely? You may know, if you are dialing in from the UK, we are still in the national lockdown, although next week we might be moving into a less restricted, some of you. We are in tier 3, so it will be even more restricted, I guess. So how do I ensure that high quality? I intend to only speak for about 20 minutes to give you plenty of time to ask questions, and just very briefly give you a bit of background where I'm coming from in terms of my educational drive, what the challenges we've been facing recently are, and I'll put a bit of a Newcastle spin on that, and then how we are addressing these here, and hopefully then initiate some discussion about your experiences and how you are addressing these challenges in your own institutions or workplaces. I don't want to spend too much in terms of the background, but it's useful to just point out that I already mentioned I'm a biochemical engineer. If you didn't guess from my name, I am from Slovakia originally. I did my first degree at the Slovak Technical University in Bratislava. And maybe you didn't know this, but at the same time, I actually gained an educational degree. So I did my equivalent of Bachelor of Education at the same time as my engineering degree. I then moved to Newcastle, where I did my PhD in bioprocess modeling, and I'm still combining both of those aspects of my interests. So I'm very much active in the chemical education, and I'm involved with a number of other aspects in terms of research as well. I've listed some here because some of the examples I will use relate to multivariate data analysis and bioprocess modeling and monitoring and optimization, which are my sort of scientific interest areas. And Hermann already mentioned quality by design and process analytical technologies. But I also listed some of the areas of pedagogical research that I'm really interested in, and amongst those most is the active and immersed teaching methodologies. So for example, we are currently working on an EU project where we are exploring virtual reality and augmented reality and other immersive technologies in teaching process safety, which is quite an interesting thing. So back to the challenges and the challenges of today's topic. So how do we teach our future chemical engineers advanced modeling techniques? And I use an example of quality by design and process analytical technologies because this has been introduced by the regulatory bodies within bioprocessing actually more than 15 years ago now, yet we are still struggling in developing those necessary skills across the curricula. And the question, I guess, more broadly for chemical engineers is, how do we encourage the engineers to develop these multivariate data analysis skills in order to help them in their daily work of development and optimization of established processes? So you might argue we already teach chemical engineers modeling skills, and this is only extending it further. I won't contradict that. Yes, we can consider it as an extension of that. We at Newcastle also thought that it was going to be important for us within the course that I will describe in a minute to develop some other skills. And one of those is critical literature review skills for their final dissertation or final project. And also presentation, team working, data analysis, report writing skills, which are all very important employability skills that we believe our graduates should have. I couldn't resist putting this here. I think everybody is familiar with various models of the Bloom's taxonomy, but the reason why I've put it here is because I wanted to show how we've structured this course to try to flip the traditional model of delivering the lower levels of the knowledge domains of the remembering and understanding in the classroom, and then demanding that the students do the higher level skills, so the application, analyzing, evaluating, creating in their own private study time. And in what I will present here, I'll hopefully show you that we've sort of tried, and students would argue managed quite successfully, to turn this around into allowing them to pre-read and understand the material at the lower tiers of this knowledge pyramid, and then engage in that much higher level analysis and evaluation and creation in the classroom environment. So let me just quickly summarize which course I'm talking about and how we ran it before the COVID-19. So this course we call Bioprocess Development module, and it is delivered to our year 4. So it's a final year of Master of Engineering in Chemical Engineering students. It is compulsory for all the students, and its weighting is 5 ECTS credits. And traditionally, we developed it and delivered it as a physical delivery. So we had what you might refer to as classical lectures, although my students would argue my lectures are probably never classical. They're highly interactive, and we do all sorts of things during the lectures. But in these 4 initial lectures, we've discussed the concepts that we will then develop further, and the material was available to the students as pre-recorded lectures and slides through the virtual learning environment, but it wasn't tested. So if you look at the true flipped classroom model, there would be material provided and there would be frequent testing of the knowledge acquired. We didn't go quite as far, so we provided the material but didn't test it. However, we discussed it in the class and referred to it. And then came that bit of a student doing the work in the classroom. So we had groups of 4 or 5 students who were asked to find a paper on the application of advanced modeling techniques for either monitoring or control or optimization or scheduling of bioprocesses, but it could be other process industries as well. And they had to post the paper and then develop a presentation which they delivered to the whole class. This presentation was marked not just by me as the lecturer, but also their fellow students, and we agreed what the marking criteria would be, not only the technical content of the lecture, so was the new material that there needed to be, but also around the presentation aspect. And then there were 5 minutes for questions. And I know your experience might be the same as ours was the first year. Nobody wanted to ask questions. So we agreed that from now on, I always pose one question myself to give everybody time to think about it. But I also pick a group at random who will have to ask a question. And obviously the students would be marked on the capability of handling the questions as well. On top of the presentation aspects and learning about these advanced methods, the students also were given a modeling assignment, which they carried out in groups. And we looked at a specific example of partial least squares. So it's just one of the techniques that we can use in multivariate data analysis. So PLS, modeling of active pharmaceutical ingredient concentration estimation, which was measured by near-infrared spectroscopy. So you can already see these are very advanced topics. These are areas that we would not normally be engaging with chemical engineering students in, but they were allowing them to develop their modeling skills much further and at the same time learn a little bit about the advanced instrumentation and application of modeling. I don't want to go into the details of how we ran that particular aspect of the course. It was computing labs. We had the groups coming in. We had the demonstrators that they were helping them with the code that we seeded, and the groups then had to develop a little bit further. We gave the groups specific tasks of exploring areas around a good modeling practice. So things like pre-processing methods to look at the data quality when it was coming in, to look at the cross-validation methods to identify the best complexity of the model, to select the variables. And then they learned how to measure the model performance, both in validation and prediction. Obviously, it would have been too much work for one single group to do everything. So we worked together as a class. We actually used Teams. So this was ages before COVID. We were using Teams to share the result and be able to then use the whole of this matrix to write up the analysis of the data and to recommend the best modeling approach and the best pre-processing approaches to achieve the goal of predicting the API concentration. The students actually felt that this was really useful exercise. Here are some comments, and I'll let you read those for yourselves. These are on the presentation, which actually was very well received. I feared that initially there would be a lot of resistance to this, because remember, this is a very new area of knowledge for them. They only had 4 initial lectures where we explored the concepts. So there was a lot of learning, but that's why working in a group was so important for students, because they could bounce ideas off. So they've learned to communicate on technical level about topics that were new to them, and then present and teach them to the class, which was really useful from their point of view. So this is how we ran it before COVID. What happened next was rather unfortunate for us at Newcastle. So not only did we face COVID and therefore had to move to a blended or remote delivery, we institutionally changed the delivery of material to the final year, to the master's year students, to something that we referred to as a blocked delivery. So instead of running across the semester, we now had to concentrate the module into 2-week block. But of course, due to COVID, we had to limit the face-to-face contact. And because we're still trying to do some face-to-face contact, but we have to do it in social distancing approach, it means that the students are busy through the week coming into the labs, for example. So we can't have many synchronous contact hours with them, because some students might be in the labs, etc. And some indeed might not even be present on campus. So some of our overseas students may still be in their countries of origins and studying from abroad. So there are all sorts of issues that I'm sure you have all encountered moving into hybrid or blended delivery much more. And those might include not just technical issues from the student's point of view, so connecting to a reliable Wi-Fi. Those of you that have been in meetings with me previously will know that my Wi-Fi is absolutely shocking, and I'm just hoping that it will last for this presentation. But imagine, as an educator, you are in a synchronous session with 150 students and your Wi-Fi drops and all of your students are out. So there are challenges that we really do need to think about quite carefully. But from educational point of view, there are other challenges that I really felt quite strongly, because I always relied on interaction with the students and that instantaneous feedback in my class. So the questions of how do you engage the students in an asynchronous material delivery, where you don't know whether they are following, what problems they might be having, etc. How do you still ensure that quality experience that they need to have? And obviously, very importantly, how do you ensure that they've achieved the intended learning outcomes that the course set out to achieve? So in terms of modifications we've introduced, we remember I said the lecture material was available before, but they were really just recordings of the lectures that I've delivered. Now we are being told you need to try to record the material into much smaller chunks, so maybe 20 minutes chunks, intersperse it with quizzes, etc. So we now have the lecture material in smaller parts. We've got it's not just MCQ, so it's not just multiple choice questionnaires. Some of the virtual learning environments allow you to do some quite sophisticated questioning. So I have a number of questionnaires set up so that the students actually have to demonstrate knowledge and understanding of what they've been through. I don't know what your experience is. People will claim that students will not do anything that doesn't carry any marks. I might disagree with that to an extent, particularly in the older, as in more advanced stages of studies. Students do understand what they want to achieve and often engage much more. But in any case, we recognize their effort in concluding or completing these quizzes, and we assign 15% of the module mark to this now. Then we ask the students to still do the presentation and use it as a group presentation because of the issues that I've highlighted before. They can bounce off ideas. We know that they work efficiently in Teams, Zooms, even WhatsApp, whatever environment they want to use, we are not limiting them. And we are asking them still to discuss the research paper they selected and to record their presentation and upload it within the virtual learning environment. And for that, they get 30% of the mark. And we still continue with questioning. This time, every group will have to question every group. We use the virtual learning environment we now use at Newcastle, which is Canvas, but again, you can use any environment for this. And as the module leader, I then assess the quality of the response from both students in terms of posing the questions and answering them, and they get 10% of the module. We are still carrying on with the modeling assignment, but we did actually need to modify it because of the positioning of the module in the year. So we have to run the module just before Christmas, which makes it difficult to bring students into the lab to do the modeling bit. And because of the issues we've encountered with the software, we now decided to run this year with an in-depth analysis of the results that they will gain from that previous year that I've just shown you. And we will have some synchronous sessions with the students and we will work through that software environment together. And that will then carry 45% of the mark for that module. In the future, what we will have to do, so as I mentioned, we will just start running the course in the next couple of weeks. So we will certainly learn a lot from delivering it as a block. And I already have noted some of the modifications we will need to introduce. As a proper engineer, you know, you always understand whatever you've put in place, this will be subject to testing. So depending on what happens, we might have to readjust the delivery. But in terms of quality assurance on the processes and the evaluation of learning outcomes, just to emphasize that we are running to the same system as we did before. So we are managing to run student feedback and evaluations. We analyze our mark distribution to ensure that there are no undue effects. And we are also in a frequent communication with our accrediting body in the UK, that's the ICME, to ensure that we are fulfilling the requirements for the accreditation. And hopefully by January, February 21, I will be able to share with you the outcomes of how did it actually go after the COVID. So watch the space. And I see Eric is ready for me to stop. So thank you for your attention, and more than happy to handle any questions. I should maybe stress that, that the recording is obviously available, but if anybody is interested in slides, then please just drop me a quick email. I think the email is up at the top, but I'll definitely share it in the chat if necessary. And I'll stop sharing the screen so that we can then all have a discussion.
Thank you, Jarka, for your presentation. We have not so much questions right now. I will just confirm that the emails of the presenters are also available on the website of the EFCE. Maybe first question to begin with, how do you ensure the turnover of the projects or the questions for the MCQ so that students do not just copy paste or like it?
Yeah, so I mean, we're following the guidelines that have been developed a long time ago for the MCQ questions, in terms of having random presentation of questions, having question banks that are similar, and each student is then presented with different answers. One thing I'm always very keen on, and my students hate, by the way, is asking questions that make them think. So a lot of my questions are not just, you know, definition and have you got the word. I still have some, because you need to, I think, layer the assessment. So you need to give a student a possibility to gain at least some marks, but then much more mark is available for the considerations. So for example, I'll give you a quick example. So we're talking modeling of processes here. An important aspect, at least from process analytical technologies point of view, is real time or timely measurement and decision making. So a question that they will be asked is, they'll be each given a different example of the process, and the question they will be asked is, what would be a timely response in this case? For those of you who are biochemical engineers will understand that in compared to chemical processes, where the reaction rates might be very fast, in bioprocesses, if I use microbes like E. coli, they might be doubling every 20 minutes. Yeah. So a 20-minute or a half an hour information is sufficient. But for a cell culture, which doubles every day, you could easily talk about every 24 hours or every 48 hours. So there are aspects where students will actually need to think about it, that the answer will depend on this, and therefore I will hopefully be able to see that they do understand. We'll see. We'll see.
Thank you, Jarka. We have two more questions. One from Tao Chen, who thanks for the talk and says the condensed delivery seems to be quite a challenge, and he wonders why it was chosen as a delivery model, and is interested to hear your opinion about that.
Okay, so by the mode of delivery, do you mean the blocked model? Because on that aspect, we had a long debate with an institution, and there are always pros and cons in terms of condensed delivery. But for this particular module, once the institution took a choice of we are going block, there was no going back. All the modules had to be delivered this way. If you mean by remote delivery and the complexity of still using the flipped, it was because of the we've ran this module for something like 5 to 6 years prior to COVID. And the students absolutely loved that challenge and the opportunity to do it this way. So I really didn't want to lose that benefit. And I'm hoping that despite having to deliver it asynchronously and some synchronously, it will still come across positively. On the remote delivery, initial feedback from the student from a student body is that they actually quite like being lectured to remotely. Would you believe it? I thought they would hate it, but to be honest, maybe it is the quality of the material, maybe it is the engagement and our responses in a discussion forum with the student to their questions, but they like the fact that they can watch it at 2 or 3 o'clock in the morning when most of us might be fast asleep. They can actually work at their own pace. So I'm hoping that that part of delivery is still going to be okay. The biggest concession we had to make this year was around the software, and that was purely, if we had been able to deliver it in October when we normally deliver this module, it would have been fine, because we would have had the opportunity to run the sessions in a computer lab. We would have been fine. But unfortunately, again, this was forced upon us by the timetabling. So we would not want to spoil the students' Christmas. And that's why we made the decision to change that bit of delivery. But they are still getting the experience, they're still running through the software, and we are still working through together with that data analysis, which is much more important, understanding what the model predictions are telling you.
Thank you, Jarka. We have some other questions about the experience you have on delivering or conducting exams remotely.
Okay, I think actually, is it one of the other speakers is going to be talking much more about remote exams, but just very briefly touch upon it. So I'm heavily involved in ICME on the accreditation, and one of the areas we're looking at is how do we robustly assess the intended learning outcomes. I'm also external examiner at various other institutions who each took slightly different approach to the exams. Some people are running 24-hour exams. I've seen institutions that run 4-hour exams. So download the questions, answer in 3 hours and upload. Obviously, there are issues if a student loses Wi-Fi connectivity, etc. How do you ensure this authenticity that it was the student that answered? Some people are actually running interviews, so face-to-face interviews with a student to talk about it. At Newcastle, we took a decision to go 24-hour exam questions, but we make them, again, much more complex. So we demand that learning from it, that thinking. And in my module, at least, it was very clearly visible. We still had quite a few students failing because they attempted to copy paste. You can deal with that, turn it in, we'll tell you immediately where it was copied and pasted from. And it was very minimal where they attempted to do that. So for each method of remote examinations, there is always the risk. I would challenge anybody who says no, there isn't. But I think as educators, we have to put in place methods such as asking questions that are not easily answered online or not easily farmed out to a company that for a fee will produce an ideal exam answer, and try to establish what the student actually has learned. So difficult, but we can talk separately because I'm conscious of time about other approaches to it as well.
Thank you, Jarka. Maybe just to finish, last question. Are the data coming from industry, and how do you manage the issue of data property? And it could be the last question there.
Okay, so for research projects, I actually always collaborate with industrialists, and we work on industrial data. We use techniques that I've described here, for example, and for that purpose, we always sign a non-disclosure agreement with a company, etc. For this module, it would be impractical. So what we did, we chose the data and a paper by a group. I can provide you with a reference, Derby et al. It's actually a reasonably old paper, 2002, and they provided a full NIR and Raman spectra on the data that they've used, so that this is publicly available data, and therefore there is no issue with regards to the confidentiality. But technically you could use industrial data if an industry would be willing to work with you, or you could even try to scale the data, industrial data, so it's still industrial data, but it is not giving away too much of the confidential information or any confidential information. Yeah.
Thank you, Jarka, and thank you for your presentation, for your discussion. I'm sorry, there are still some questions pending, but we have to go on.
I'll answer to the questions within the chat so that everybody can then see as well the responses, if that's okay. Yeah.
Thank you.
And thank you for listening.
We had one question of someone. Yes, the presentations are being recorded, and you will find the link in a few days or a few weeks on the website of the EFCE. So the next speaker is Marcel Liauw from Aachen University in Germany.
Okay, thank you. And this should be my screen. You can nod if you see it. All right. So welcome. My name is Marcel Liauw. I am from RWTH Aachen University in Germany, and I will talk about student-generated exams. You see a quote that I put on there. Rich Felder once was told by a student, just tell me exactly what I need to know for the test, not one word more or less. And that is something that may be in the back of our minds if we go through the slides and what we did here in Aachen. Okay, the regular class is a reaction engineering class. It is in the master chemistry. The topic is mixing in several systems, homogeneous and multi-phase systems. It's dimensional analysis, correlations, and scale-up issues. I heavily work with material by Mark Telford from Brightest that is very helpful. It is in spring, it is 2 hours per week, 3 ECTS. It is compulsory to a certain kind of students with a certain specialization, and I have about 80 students each year. What I regularly do is they design a problem on the material that they turn in with an answer and an explanation, and if it is nice, and it usually is nice, they get a bonus of 1 step of a grade on the exam if they don't fail. And the final exam is a 60 minutes or 1 hour exam that addresses both lower and higher order cognitive skills. Now you see that they are sitting close to each other, so we will look at alternatives. Before we do this, we look at a regular exam. It comes with a double-sided compilation of formulas. I do not insist on learning by heart all the formulas. I say you can look at them on your smartphone anyway, anytime, so why don't you just take this? I do expect that if the formula is there like 3 or 4 times, slightly differently, they can identify by looking at the dimensions, for example, which one is the correct one. And also, usually I do not permit calculators, only mental math, because in engineering you need ballpark results, so you don't necessarily need the exact number. And if you look, for example, at this correlation, you see that the density of the solvent, which is water, has an exponent of 0.66. Water has 1,000 kilogram per cubic meter. So how do you do this with mental math? And 1 or 2 students per 80 usually tell me that 1,000 to the 0.66 is pretty much 10 to the 3 to the 2/3. And that reduces to 10 square. And of course, then you can say that this is 100. And because 0.66 is a little smaller than 0.6666, the true value is 95.5, 4.7% off, so that's good enough. Okay, the advanced problems that I deliver myself to the students to show them how it could look like is that I take something I find in literature like this resistance tomography and Italian water dispersion, and how then the impeller speed was increased from 300 to 350 RPM. And the question is which liquid was the dispersed one, toluene or water, and which one was the continuous one, and what was the volume ratio. And of course, because water has a higher conductivity, you can say that you had initially toluene dispersed and water continuous. And then also from the material that we had in class, you can say that most probably you crossed the inversion line at the upper light phase volume fraction, so it's 70% dispersed toluene in water. So this is how I would like the students to think that I can apply what we learn to a given problem. I show you from a previous year a student-generated problem. The student said, I carried out a reaction and I looked at the product, particularly the amount of product that I got from there. And I did vary certain things like the stirring rate or the addition rate of the second component, or also the position of the feed. It made these drawings, and by evaluating it with the Born scheme of mixing problems, you can find out that the first one, the pink product, mixing has no influence. The second one has a micro mixing problem, and the third one is a macro mixing problem. Okay. That was the last years, but now we have no final exam, so we need to come up with something. And the question is, could we do a graded homework? How do we do this? And you see that we did have a bonus in place anyway. So I thought, like, why don't we make a complete exam that the students make themselves? I do hear a voice, do I? No. And then I saw that Dr. Fu Yunyu from National Cheng Kung University in Taiwan has a series of papers. The first one I'm aware of is the one that I quoted here. What she looked into is student-constructed tests. And the point is that in opposite to the student-generated questions, the whole tests will need a complete coverage of main ideas. So it is more than just a single question that you make. And you have to weight the test items and to sort them and to rank them and to grade them. So these are things that come on top of this. Now, basically, I wanted to tap into this. And I had, of course, to prepare the students. So the students said, how do we make problems? And you see that we had topics like these: homogeneous, macro mixing, liquid-liquid dispersion, gas-liquid dispersion, liquid-solid dispersion. And you select a topic like gas-liquid dispersion, and you line up the details, the flow number and the fruit number. And then you could pick a variable or a parameter. You see G, which is the gravitational constant, which is relevant in gas-liquid dispersions. And now you see at the upper right corner HAZOP. You can take the HAZOP approach that is known to work with guide words and apply the guide word less, for example. And what would happen if G were less than the G we know? And then you build a problem and you say, we have an experiment that worked nice, and now we put it on the moon. And of course, on the moon, G is smaller. And then you can see that the impact on the fruit number is only this one. So you can quantify it, and the ratio that you have to change it is by a factor of square root of 6. So that was an example that I gave them how they could approach the problem of designing problems. The homework thus was, please create an exam, including on the sample, and please add also a feedback on the homework replacing the regular exam. One thing is that I said at least one problem should be a linking problem, such that it links to other classes that you took, or other courses, or other practical courses, and that you try to find how could our material help you in their environments. And also please specify if calculators may be used or not, and also if you will have a formula handout or not. And if you prefer making a test or taking a test, like making like now or taking like usually. What happened was that we had 77 exams coming in. And the interesting question, would you rather make a test, were more than half, were 41 students. There were 8 students who said, well, I rather write the test like the traditional ones. And there were 9 who said, well, either way is fine with me. And the interesting thing was the many students who said, I really enjoyed this, and I think that I prefer making a test from taking a test, were like, I have more time because I could take 2 weeks to work on it. It was also, I go deeper into detail, I go deeper into the material, and all of us who have prepared classes and lectures know you learn most when you prepare a teaching. And that is what I myself had done with a friend of mine in my study. That is how we prepared for exams, not reading the material, but thinking of questions for the other one to solve. Interestingly, the calculator is something that most of the students said should be possible to bring, 65 from 77, but 7, like 1/11, said, no, we rather also think that students should be able to estimate a good number without a calculator. And then with the equation handout, 57 edited, 10 said no, students should learn formulas by heart. It's not that difficult. And if there is something missing, 277, these were the students who did not give any information on how they preferred it. I picked one thing. I have counted in the 77 exams how often the gravitational constant was changed, because that was the example that I given them, and 11 students used this. 1 also went to the moon, 5 varied the whole thing and went to Mars, 1 to Jupiter, 1 to Mercury, 1 to all other planets, 1 had a space flight and 1 had a parabolic flight. Okay, so this is an example that students may not have thought of all new questions, but also recycled some questions that were there. In the box, you see that quite several students pointed out explicitly that I said we are not trained to do this, to construct problems and also to attribute grades to them. So that is probably something, if I want to go further on this path, and I think this is worthwhile reflecting, to really train the students. Like, how do I look at material and see how I can ask a question that relates to this? Several students, like I said, pointed out that they learned more intense. And 1 or 2 even said, we anticipate that we even have a better retention, that it will stay with us much longer than if we had learned for an exam the traditional way. The question that should be a linking question was interestingly something I did not know what would come up. And I had 1 or 2 classes and courses from colleagues that I thought would be the ones that we can link to, but I found other classes, other courses that were totally thought of by me, and that I did not know that it would relate so nicely. And that was also something that the students cherished, that I said, I wouldn't have realized that the things have to do with each other, but now I saw the link between the two. Okay. I show you two questions that the students came up with. One is you have a proline catalyzed aldol reaction in lab scale, and you want to scale up, and you know that enantiomer selectivity improves when adding a bigger or larger stirring rod. So if we go to scale up, why would we want to try to find other factors than the stirring rod length? Why don't we just scale up or make the stirring rod longer for 4 points? Okay, and if they followed the class, then they know that the power depends on the diameter of the stirrer to the 5th power. So if you double the size, it's like a factor 32 that the power goes up. And that is something you may not want to have, so you rather look at other factors. A very nice question. And then another student said, you have to suspend spherical gold particles, but you have to do it in space. And this is the diameter, and the geometric parameter is such, and the impeller diameter is so, and water is the fluid phase. So how fast? And that student explained in his comments, if you really understood it, you know that because there is no gravity, you get the 2 points that are in the problem for saying you don't have to stir at all, right? Because there is no gravity pulling it down, so it will be suspended anyway. Very nice questions, and I think that you can get 2 points within 5 seconds and move on. Interestingly enough, also, virtually all students explained how they had problems for those who were a little more challenged and where they could collect some points to at least get some. And then they would have some more intricate questions to distinguish between the very good and the sufficient students. So there was always thought of also the weaker students who needed some material to have a chance to get the exam. Okay, so I thought of a 50-minute talk. So basically, let me summarize. You see that we had 77 students, and half of them said, this is nice if we can prepare an exam ourselves. I think we really have to exercise this more and practice this more because even the very motivated students sometimes said they liked the techniques and they liked the ways of going about making a good, nice problem. So we probably look at this even more. They pointed out that they learned in a more intense way, and both the students and I myself became aware of links between classes. That is something we do not do very often in our study, I need to confess. And coming back to the motto of today, what about the learning outcome? The students and also I had the impression that the learning outcome, that they get acquainted with the material and that they work with it and they can work with it, was met equally good or even better with this. So if we want to look at an outlook, I remember that for the single student-generated problems that we had for a few years, what I had introduced this year in another class was some peer comments. So that the students post their problems and then the other students look at the problems and give comments like, you made a mistake there, or I not like it very much, or you could improve it. It was a very nice atmosphere in the forum that helped to do the quality improvement of the questions. I think that building into the whole thing of student-generated or constructed tests, also some peer assessment would be a very nice thing to add. Okay, with this, I think I would like to stop, and I would be happy to discuss about it.
Thank you, Marcel, for your presentation. Yes, we already have some questions. Okay. The first one from Hermann Feise. I can read it. How much did the submit exam vary in the level of complexity or difficulty?
How much?
How much did it vary in complexity or difficulty?
There was I need still to analyze more, but there was what we usually have is a distribution. Okay, so we had some students who made very nice and intricate problems, and then others who have a set of very simple problems and who did not get further. I think that is what the question was, right?
Yes. Yes, the question is, how do you compare the different exams performed by the students? How can you grade them?
I think it's comparable in most cases. Roughly 3/4 are exams that they turn in that I could have given to them. 1/4 is probably simpler than that. So it does have the simple questions, but it is then at a certain point missing the more complicated questions. Yeah.
How long does it take to correct these exams for the teachers?
Yeah, it depends on the person to correct, because I know from a special issue of the ECE journal that there will be a paper by Margot Vigendi who did a portfolio thing, but also something similar in the sense of what is the grading. And she said grading was more or less like with the traditional exam. I myself took much longer, and I still am looking at criteria, because of course I tried to come up with some rubrics, but I think the rubrics need really to be adapted more to this certain set. This is still a thing that I need to work on to really have a go on the correcting.
Thank you, Marcel. There is another question from Luis Miguel Madeira, who says it's curious to see that engineer students don't feel comfortable with mental calculations, rather prefer using calculators. Any comment or justification for that?
Oh, thank you for the question, because I was not clear. On the first slide with content, it said it is a class in chemistry. It is not engineering, it is chemistry. I am a chemist myself, but I did chemical engineering with Dan Loos and Gerd Emig, so I think almost like a reaction engineer. And that is why I cherish that you go look at numbers and don't look at the pocket calculator at once, but try to get a feel on the order of magnitude and so. And this is something that is not, say, trained in schools, in Germany at least. There is a huge availability of pocket calculators now on the smartphones. So you just put a number there. But I saw particularly in the student-generated problems, that sometimes they come up with a so-called solution, and I look at it and I can tell them, like, this is not possible. And I can even spot what the mistake is, that I say it said square, but you didn't square, or it said cubic root, but you took a square root. You can see it from the order of magnitude. And this is something I try to exercise with the students over the whole semester, but most of them loathed it. They don't like it. So last year I permitted calculators. You would have expected the grades to go up, but they didn't go up. Because I never punish them for a wrong calculation if from there on they calculate the next steps correctly. So I take it step by step, and so you don't lose too many points if you make a small mistake or so.
Thank you. Thank you, Marcel. Maybe a last question from me. How is the workload included in the how the time for preparation of such exam is included in the whole workload of the students, because it may take them a lot of time to prepare an exam.
Right. The time by which I was able to really tell them exactly this is what you need to turn up was already too late in the semester. So it started running into the other exams that took place. So the students informed me, and I postponed the deadline by 10 days, and that made it possible. But they said themselves, maybe next time the homework is given halfway through the semester. The students themselves commented that some took like twice as long as they would have learned for an exam, and they said it was roughly the same time. So it is comparable, and those who took twice the time probably could have done it a little faster, but then they liked it then.
Thank you, Marcel. There is still a question pending on the question and answer regarding the grading of the exams, but since we already spoke of that during the discussions, maybe you can write a few more comments on the question and answer.
Okay.
So thank you again, and we'll leave the floor to the next speaker, who is Szekely from the Budapest University of Technology and Economics in Hungary.
Thank you, Eric. I try to share my screen. Is it okay now, Eric? Thank you. So welcome, everyone. I think that some thoughts I'm going to share with you are very similar what you could find in the previous presentations as well, but I hope that some additional or some different views can be also shared. So actually, I'm going to show you what we did in the springtime. So we tried it and also have some results regarding the students' feedback. And actually the biggest question is, at least for us, is how to incorporate creativity and innovative thinking, team working, and other soft skills in the education, especially on the master level. But before coming to that point, I would like to tell a bit about myself or my university, not that much myself. So I'm from Budapest, which is the capital of Hungary, and we are issuing at the Budapest University of Technology and Economics 70% of the engineering degrees in Hungary. So I would say that this is a big engineering university, also quite a large number of students, including internationals as well. And the university has 8 faculties, and one of these faculties is the chemical technology and biotechnology I'm coming from. And to understand the concept of these courses and also what our problems with the remote teaching are, I have to add that we are very much research-focused faculty and research-focused team, I would say. So typically we teach soft skills, including team working and communications and all type of writing summaries and writing proposals, this kind of things, in person when a student joins the lab, the research laboratories. Actually, we are a bit less than 2,000 students, including more than 10% of international students. They are studying in the English curriculum of chemical engineering. And also we are having a doctoral school and accredited talent center. And these work really together with the research groups. So we do our best to involve the students as soon as possible in research and development, because that's part of the curriculum. But now I would like to focus on something else. But before we can change to that, I would like to show you the size of the different curricula we are offering. So we are having bachelor in biochemical engineering, chemical engineering, and environmental engineering, and a bit more spread in the master courses. But you can see that the number of students in the bachelor and in the master per year are roughly the similar. And we are also having quite a strong doctoral degree curriculum. What I would like to emphasize is that we all had common troubles and experiences when we shifted to this unexpected remote teaching in the spring. I just would like to refer to what Jarka also said, that yes, it worked and we found a lot of interesting things, but there were problems as well. On the left hand, there are the pros, and right hand, the contras. So actually what we found, I think you might agree, that the classical lecturing, frontal teaching, it was quite okay. It was possible, either in a form of video conferences like we are having now, or webinars, or in form of recorded lectures. But we had several troubles. One of those, which Jarka also mentioned, that those who are using modern teaching methodologies and interactive lecturing, they had a lot of problems on the online space. And on the other hand, professors who are excellent chalk and blackboard type teachers, you know, who really go there and tell the lectures and write all the equations on the board, they suffered a lot. We also saw that students were very happy to attend the online lectures. So typically by the time when the closures have been in March, also here in Hungary, we were already in the third month of the semester. And during that time, typically we have around a 50% attendance rate in the lectures, and it increased to 80% when we switched to remote teaching. But I must say that it was just a matter of time until the students realized that they can revisit the lectures at any time because of the recorded lectures. And in this autumn semester we are having now, the attendance number dropped a lot, which is again a problem regarding the interactive teaching. And also we found that the lack of social interactions during teaching and learning, and not only mentioning these interactions between the teacher and the students, but between the students as well, made it difficult to achieve some learning outcomes. And especially including the team working and presentation classes was something important, was so problematic. The video conferences were found very efficient for oral examinations or face-to-face examinations, so there was no problem with that one, especially, I mean that it's something we might use later as well, but there were serious concerns related to the assessment on the written form, and since we are having relatively larger numbers in certain classes, so more than 100 persons, face-to-face examination might not be possible due to the number of the teachers available. So taking all this into account, I would like to show you what we experienced in a case of a special class. This special class was a form of virtual conference, and we had competing teams, and we also incorporated the peer assessment Jarka was already mentioning, but also the lecture of Marcel was including a certain sense. So the idea was that we are having projects, we form teams of the students, and students work in teams to solve those projects, and external supervisors were provided. So we were 3 teachers in the course with 3 different topics offered to the students. And the teams had to present their project at the virtual conference. Also, we did our best to enhance the interactivity of these virtual conferences by adding extra scores on the questions asked, and also asking the students evaluating each other's based on the performance of the presentations themselves. And in several steps of the course, we had the peer assessment. So one is the evaluation of the presentation, and the second is the evaluation of the participation of the students in the teamwork, because this is also a very critical issue, because if you bring together a team, sometimes you have the problem that one or two students in a team of 4 does all the work or do all the work, and the others are just sailing there. Or it's also possible that everyone has his or her own share. So the idea was that it's a game, and the teams are companies, and the companies want to submit an EU pre-proposal. We called it pre-proposal because it was not so detailed as a real proposal would be. They just a hint of idea, also some description of the possible implementation of the project. And they want to form consortiums. So there is a leading group who is looking for consortial partners, and there are competing groups who are applying to be partner companies with the consortium leader. And we had special learning objectives. I mean that I'm talking about chemical engineering master course, really relatively a high level, so last year course. So we would like to focus on improving team working competencies, including working in a multicultural environment. This is especially important because in Hungary, a lot of students will work in a multicultural and multinational environment, but during the studies, they are just among Hungarian students. But since we are having also English curriculum, we could combine the two groups to work together, and that was the idea. So we had Hungarian students and we had international students, and we divided them to 12 groups, and also made sure that there are international students in each group to ensure that the working language will be really English, and also that they get to know each other much better. The second goal was to have basics of proposal writing and presenting ideas. So they had to submit a written material made as a product of the team, and also give lectures about their ideas. And also, of course, this is an engineering study, so we wanted them to familiarize themselves with novel technologies, evaluating advantages and disadvantages, and also to get some ideas that if you find a research paper or some description of an innovation, what could be the problems to bring it in a real world application? Because I think if some of the students is going to work in a tech transfer, that would be the most important thing, how to evaluate that. Is it a realistic idea, which I found in a research paper, or not? So we give broad topics. We really did not say them what to bring as a solution, and we let the groups to develop their project ideas themselves and evaluate the pros and cons of the project ideas. And last but not least, we wanted them to improve their professional vocabulary and communication skills in English. And also, it was not only about presenting in English, but also expressing critique in English, because it's sometimes quite difficult how to tell it politely that you have some doubts in the results, or some points of the presentation of the written material is not really strong enough to be presented, but meanwhile, don't be rude. And this is also something you have to practice as a student, at least in my opinion. So the course started with the introductory presentation, which covered how to work in teams, giving some hints, starting from that you need a leader and you have to define what your group is for, and also taking responsibility and keeping your promises, and how to give a suitable and applicable feedback to your teammates. Also, we discussed how to write a proposal, what are the key issues of writing a proposal. So we are talking about last year master students, so very soon they need to write certain proposals, if not more than job applications, but also certain students are heading towards research, so they might read and write research proposals. And also how to make a presentation. So we gave a time frame of the presentation, ideas how it should be visually supported, how to ask questions, real ones I mean, and they got points for the real questions. And also the questionnaire was put together, which we asked all students to fill. I mean, not those who were presenting, but all other students from the other groups. So the result of this whole project was absolutely exciting, absolutely exciting. So we had 3 topics. The one topics we gave is biomass 2020, upgrading a biomass waste, which is relevant in Hungary. That was the description. And they came up with an idea that they are planning, so the consortium leader team came up with the idea that they would plan to make a firm producing polylactic acid filaments for 3D printing from corn stalk. So using both the lignin and the starch fraction of the biomass waste raw material. And the partner companies were offering technologies for that idea, including the chemistry and the technology, and also how to produce the filaments themselves. The second topic was high added value products from byproducts of agro-food industry. So it's not from the agriculture, but from the agri-food. And they came up with an idea that they would like to produce antioxidants for the cosmetic industries from pumices of fruits, mainly peels of apple and grapes, which is widely available in Hungary, and there is a lot of such waste from the juice producing industry. And the different partnering companies who competed for being a consortium member offer different extraction and particle formation technologies for the antioxidants. And the third topic was the reusability and full recycling of lithium-ion batteries from electric vehicles, so from cars. And the idea was that, which the consortium leader company brought in, that they want to reuse, first of all, these batteries for different purposes. And there was a company offering the full solar powering solution for an industrial site nearby in Budapest. Another was suggesting that a new stadium, I mean that in Hungary we are building stadiums nowadays, it should be self-sustainable from a power point of view by using solar panels and storing the energy in these used batteries. And the third company had the idea to disassemble these lithium-ion batteries and offer some recycling possibilities based on the literature. I do not want to go into details that what was the exact idea they had. What I wanted to say is that these were absolutely creative and not given ideas. So they brought in their own ideas, and we saw that the students were really excited. Coming to the evaluation, because I think that's one of the important part for us as educators. So we asked, first of all, the students to fill certain questionnaire related to the presentation they have listened to. So we had the video conferences in different sections. So first section was the video conference of the consortium leaders who showed their ideas. And then later we had 3 different video conference sessions in 2 weeks distances, when the partnering companies brought in their ideas and showed what they are planning to offer. And after these presentations, all the other students were asked to fill this questionnaire about the presentation. So one of the points was to share their opinion, critics, comments including the explanation why they has that opinion, why they have that opinion. And also we gave some aspects of the evaluation of the answer, because the students submitted these answers, which we gave as anonymous feedback to the students who made the presentation. But meanwhile, we as teachers evaluated their feedback based on if it was relevant, if the style was suitable, if they understood the concept of the presentation, and also given written answers, written evaluation, that what was the problem with the comment they made, if there was any, and also they got some points on that. The second part was evaluating the presentation itself. So like a presentation, so was it creative, quality of the work, quality of the presentation, supporting visual aids and so on. And again, the answer was evaluated, and there was a possibility to raise further questions related to the presentation. But actually the majority of the points was given for the questions asked on site. So during the video conference, they could ask questions. And since these teams uploaded their presentation slides and written materials before their presentation was done, we really saw that the students prepared with very relevant questions. They cross-checked the presentation and the written material and found some mistakes and added those. They made some additional calculations and questioned the presenters. So it was really exciting how well they prepared for the questions for the 10 points online. But also they had an additional possibility to ask questions. So the role of the questioners was dual. One of the role was to give a feedback to those who did the presentation anonymously. So it was important that they don't know who had a negative or a positive opinion on the presentation they made, but also it was important to score themselves. And as you see, well, it was not a very nice distribution, what we gave for a certain question, but not everyone got a 5. So there was some weaker answers where we could really try to teach the students how to express themselves in a professional manner. The written proposal, which have to be submitted at the end of the project by the consortium leader company partnering with one of the selected other teams, included the presentation of the project idea, some flow schemes, environmental and safety aspects, timeline of the project, economics, and so on. And it was evaluated together again with the team members. And this is what I would like to emphasize here, how we did, because it was really exciting. So we made a general recommendation for the points of the submitted final pre-proposal. And we asked the team members to make a share of these points among themselves, with giving a feedback to each team member by themselves, how well he or she participated in the different tasks, how efficient he or she was. So coming to the conclusions, what we found is that even if there are no labs, the virtual conferences is really working fine to improve the presentation skills, and also for team working, it's really nice and efficient, so we should not afraid of it. And the students benefited from very different points of view. And what was really nice, that the master students have amazing ideas and we are really creative, and we need to think on how to support them to use this creativity they have in themselves, because the learning process is much more efficient in that sense. Of course, we asked the opinion of the students, and most of them was really excited. They found it a fun course and was really positive feedback, mostly on the video conference as well. And we got some negative feedback as well. I mean, that's normal. You cannot do anything which is good for everyone. And by this one, I would like to thank your kind attention, and questions, comments, concerns are welcome.
Thank you, Thank you, Edith, for your interesting presentation. We now have time for questions. Some are coming. The first one, I'm reading it. It just came from Luis Miguel Madeira. He said it's a nice idea and presentation. He noticed that you have one or two foreign students in each group. This means that you or the teaching staff created the groups. What were the criteria apart from the foreign students? And how is this appreciated by the students? In most cases, they prefer to make the groups by themselves.
Yeah, we formed the groups also online, so it was just we used Moodle system, and we made a table in the Moodle system and set the preferential criteria for forming the groups. So we asked them that at least one international student is in the group. If there are two, they should not come from the same country. And we also asked the Hungarian students not to form groups with their friends, but try to make a heterogeneous group. You have to know that in our master studies, we are not only receiving students from our own bachelor, but also from other universities in Hungary. So we asked them to try to form heterogeneous groups as much as possible. But we did not really force them to do so. But mostly they followed. The only thing we checked that there must be at least one and maximum two international students in the group, but otherwise they did it. Actually, it was quite tricky because when I closed the formation of the groups, there were two groups not meeting these criteria, so I had to ask them to change, but I mean, this is how it's done. Yeah, it was a bit tricky.
Once again, a question of me. About the workload for the students to be involved in such a project, because it seems very consequent.
They worked a lot. I mean that it was really, really incredibly a lot, but we did the course very similarly also in the in-person teaching time. So it's not really a big difference. So this is a course running for 6 years roughly with basically the same idea. And this is a 5-credit course, no formal lectures, no labs. So, well, I mean, it was the credit. But it's really lovely to see how excited they are to do something on their own. So probably they spend more hours than it's the 30 times the 5 credits, but they do it.
Thank you. And so, as I understood, you mix both in group evaluation by the defense of the project, by the report, and also individual evaluation by the interaction of the students during the presentations and so on. So, do you see some differences? I mean, for example, a group that made a very interesting project and one student that did not perform the individual evaluation.
Could you please repeat the last?
So are there some differences between the group evaluation and the individual evaluation? So can you identify a bad student in one group?
Yes. I mean, that what I say is that the students read, they were very strict with each other. So when at the last point, we said that, all right, your project was 100 points, and you should make a suggestion that what should be the share between the group of the students, and make an explanation that why do you think that would be fair. Then they wrote it down that yes, I think so, that in this work he participated well, but in that one he was not answering the emails and so on. And when you see that a group of 4, 3% says that someone is not working hard, then I mean that it's obvious. So it was very homogeneous. So there were no debates, luckily.
Thank you. There is also one question of Hermann, who says you had partner companies for the project. How did you separate out their contribution from the contribution of the students?
No, probably I was not exactly clear. So we did not have companies. We formed teams of the students and asked them to create a company. Imagine a company. They created the logo themselves. They named the company themselves. They wrote down their company profile. So like it would be a spin-off or a company with a history. So it was not a real company. It was an imagined virtual company. So it was fully the students.
Thank you, Winnie. I don't see any other questions. There was one more general question about implementing block mode delivery, but Jarka gave a rather detailed answer, so I think it's good for that. So thank you, Edith, for your presentation.
Thank you.
I think it's time now to finish this webinar, if there are not any other questions. So thank you very much for attending such a spotlight talk. We all remain available for any question or discussion by email, of course. The presentations have been recorded. They will be soon available on the website of the EFCE. You should receive some information about that. So thank you. Stay healthy. Take care, and best wishes for your future online courses. Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.